Today I am going to tell you about some vector analysis techniques. So we will learn these things like feature extraction, attribute-based analysis, and pie chart. We will show pie chart on the map, and we will do line-polygon intersection in QGIS. All the things will be done in QGIS here, and these are other few things we will do in this practice. And we use the data from different sources. So district boundary and roads, etc. Of Nepal I have downloaded from this website. You need to log in to get the data. And another is education data, which is downloaded from Central Bureau of Statistics of Nepal. And one is Landuse data downloaded from EasyMode, and few other data I have prepared myself, and from different other sources are like this. So we will start with feature extraction. So we will learn a few new techniques by doing this. So I have the vector data of districts of Nepal, which I already downloaded from the source I already provided you. So this is the district data I will show you. So this is the district data. So what I do is I create a grid 1 degree by 1 degree as shown here. So we will use this vector research tools and create a grid, and we will read the extent from the map, and then we'll cover whole the area of Nepal by rounding down the minimum value and rounding up the maximum value. So let us see how to do it. It is a very small practice and it will not take more than 1 minute. So what we do is vector analysis tools, research tools, and create grid, and we will create a rectangular grid. We can create others also. So grid extent we choose from the layer. So district. So we can see that it has a few decimal places. So we remove these decimal places, and so 88 we should round up it because we are going to cover whole the area of Nepal. So minimum value will round down, and maximum value will round up. So now everything is okay. So we will create a grid inside the geo package. So let us say we create VA practice, vector analysis practice, and output name is grid, and we run this. So we can see that a grid is created here, but some grids are not overlapping the boundary of Nepal. So we remove these non-overlapping grids. So we have different ways of doing this. So we can find like location by extract by location, select by location. These are the few things we can do. So we will select by location. So if we double click this, we get the tool interface. So we will select features from grid which are intersecting this district new and create new selection. Close. And now we can see that only those grids are selected which are overlapping the boundary of Nepal. So we'll remove other grids. So we can do this by different way. So for example, we can just right click this one and then export, and we export selected features as. But another way I will tell you, by using this attribute table. So currently the overlapping polygons are selected, so we invert the selection, and now non-overlapping polygons are selected. So we edit and delete this non-overlapping grids. So now it is finished. So we remove this toggle and save the grid. So this is all about creating grids overlapping the boundary of a layer. Now we are going to do attribute based analysis, and we'll create a pie chart based map. So I will use this census data downloaded from this CBS website. So let us check what are the attributes of this census education. So it is a tabular data, doesn't have any location information, so we can only view the table. So we can see what are these attributes. So total population means 5 to 25 years old total population by district, and it is male and female population, and it is population of child who are going to pre-primary school, and this is the population of primary level children, and this is lower secondary, and this is upper secondary, and everything is divided between male and female. So we will use this census data and this district data. It is downloaded from the National Geo portal of Nepal, which I show you. So now we join these two layers. So double click this one and then join. So we join with the census education. So census education district name and district and target field is from census education, so it is district revised. So we will use this revised district name and OK. So if you now see the attribute table of district data, then we can see that these 5 attributes belong to this district new, and all other come from census data. So based on this, we can now create a few pie charts. So let us create a pie chart based on the ratio of male and female population of 5 to 25 years. So we need to find the ratio of population, so we should write here ratio, and then it should be real value, and it is population male and population female. So we create from this field values. So census education female, male, and we divide, and we can write into 100 so that we get the percentage. And it is long decimal number, so we can round it. For example, round it to 2 places, and okay. So we get a new field which shows the ratio of female versus male. So we can symbolize based on this. And in this video I will going to tell you how to create a statistics, summary statistics by state. So we have 7 states. So for each state we create the summary statistics. So let us use summary. So statistics by categories we can use. So district new, and but before that we need to save this one. So we save this, and now we create the summary statistics. So based on this female to male ratio, sex ratio, we create based on the state, and we can save this data as statistics by category. So we use the same geo package, vector analysis practice, and so we create the statistics table and we run this, and then we can see this is also non-geometric table, non-spatial table, and we see that for each state the number of districts are here and unique values, so it is a bit different, but anyway. So mean and max. So for example, for state 7 the minimum male to female to male ratio is 99.98 and maximum is 100. 11 or 112, and we get other statistics like average, median, quantile, and other things. So now we can create a polygon of state and then combine with this ratio and find the average of each states and show it as map. But I'm not going to do that. For the symbology and other things, we can use my past videos. So next one, I'll try to create pie chart based on the population of male and female child or female people going to lower secondary school or primary school, let us say. So district new, double click this one, and then we use this diagram, and for example we use pie chart, and then attributes. So we use this female primary, so Census Education female primary and male primary. So we change the color of this. For example, male we use green, and female we use pink. Okay, and then apply. So now we can see that male and female primary school going children percentage. So for almost all the district the value is same. So we can change the size. For example, if you don't like this big, so we can change it like this, and we can also check others. For example, we can remove this not primary but lower secondary. Oh, so it is only changing the legend. So let us say lower secondary. We need to change the attribute also. So we need to change it to LS, and similarly we need to change it to LS, and now we can check. So even lower secondary, most of the places the ratio is almost same. In some cases even the number of female is higher. So this is how we can create pie chart in QGIS. So now we are going to do line-polygon intersection analysis in QGIS. So first of all, I use this district new, and then I use this Nepal all and road. It is here, so we can see the road. So it is very simple in QGIS to intersect line and polygon. So in this practice we will find the length of roads in each district. So from vector geoprocessing tool we use intersection. So in this case we are using line and polygon intersection. Generally we do polygon intersection, but in QGIS we can also intersect line and polygon. So we use this trans ln as input layer and overlay layer as district, and then create a new intersection layer. So in this case I am just going to use temporary layer which will be deleted afterwards. So it takes few seconds. All the roads which crosses multiple districts will be clipped by districts, and the attributes from district will be added to the roads. So let us wait for it to finish. So we close this one. Now we can see the intersected roads are same as this, but it is divided into districts. So you can use the symbology tool to differentiate the colors. From symbology we use categorized symbol and then the value by district. So newly created district and classify, and we can also use a bit bigger, broader, wider symbol, and then we can see that roads are shown in different colors, and we can also find the length of this road. So now let us try to find the length of roads in each district. So there are various ways we can do that. So first of all, let us find the length of each road sections. So just click this attribute table and calculator, and we write the name of field as L and output type as real values, and we find the length in kilometers. So but our calculator will give meter length. So if we use $LENTS, then it will give you the length in meters. So meters is also okay, and we use round and round the length to one place, so because it is meter, or we can okay, so we can reduce the precision to reduce the length of size of our output. So we can keep it like 8. So we can see that length is here. So if we toggle editing, then we can save it. So these are the length of roads, and we can use the summary statistics, and in the same way we can find the length by district. So we can see that in the district, multiple road has the same district name. So if we find the statistic sum, then we can sum the length of line. And otherwise there is another tool called sum line length. So we can use this sum line length tool, and for this we don't need to intersect. So polygon is district and lines are the, even we can even use this trans ln to find the length of line. So but let us use this intersection. Lines length field name will be length, so a new field will be created and number of roads will be written in this field. So we can change, keep it as temporary layer and run. So now we can see the length of roads by district. So for each district we can see the length of combined length of the roads. Now we will create Thiessen polygon and try to understand what is it, and we will use rainfall data, which I provided in this geopackage file. So let us this is in this rainfall data, rain data.csv, and we will create point from this point shape file from this tabular data, and then create Thiessen polygon. So let us first display this table. So it is inside this sample practice. So sorry, this is rain data.csv I have downloaded, so I can just display here, and it is tabular data, so it will shown like table. So we have latitude and longitude here. So from this data we can create a spatial data using point from table, create points layer from table. So this is the tool we are going to use. So rain data we are going to use, and x is longitude and y is latitude, and then we create point data, and for this practice we'll just create a temporary layer. Otherwise, if you want, you can save it to some vector data like geopackage or shapefile. So just run this, and we can see that we have this rainfall data here, and it will have all the attributes from this CSV file. So purpose of this practice is to create Thiessen polygon. So in GIS, QGIS, we can find this tool, geometry tools. So this Voronoi polygon is same as this Thiessen polygon, so it is just the difference of name. So points from table we are going to use, and this one. So Voronoi polygon will be saved here. So just run this one. So this is the polygon we just created. So let us try to know what is this. So the polygon will be created in the extent of this data layer, and for every polygon the nearest rainfall station is this point. So these all these polygons are created in such a way that for every space inside this polygon, the containing rainfall station is the nearest station. Now let us try to learn what is this nearest neighbor analysis. So in this practice we will use two point data. So you can use any kind of point data. Like for example, in the urban setting, you can find the nearest hospital from every residential building or so on. But for this practice, I am going to use these two settlement point and trans PT. So this settlement point is the settlements inside Nepal, and trans PT is the layer representing airports. So first of all, I will display these two layers here. So both layers look similar, so I change the trans point symbology. So I will make it a bit different, not very big different, but and I change the color to pink. Apply. So now we can see that these airports look a bit different from this settlement point. So we are going to find the nearest airport for all the settlement points. So what we do is we use vector analysis tool, and we'll find the tool which we need. So this is this nearest neighbor analysis tool is used for a single layer. Within the single layer we find the nearest neighbor, and for the two different layers we use distance matrix. So let us try this one. So input point layer is settlement point, and we use this unique ID FID, and the target point layer is trans PT, and we use this FID. So for each settlement point we get the distance from all the airports if we use 0. So if we change it to 3, we will get only 3 nearest airport from each settlement point. So let us run this. So we have very few input parameters to enter here, and now run this. So it says that input point is a multi-point layer, so we need to change this multi-point layer to single point layer. So let us first do that. So we can find multi-part. So there is a tool called multi-part to single parts. So we use this tool to change this settlement point and trans point to single parts. So let us save it like vector analysis practice, and so you can write any name settlements and run this, and from the same tool we can again run this airport. So we don't know whether airport is also single part or multi-part. So in this case we can just change this to airport. So it will be saved in the same geo package with the different layer name. So both are now, this airport and settlements, both are now single parts. So let us try to run the distance matrix again. So distance matrix here, input point layer is settlements, newly created layer, and target point is airports. And again we will try this 3 nearest neighbors, and maybe we can save it to the same this practice file and write the layer name and run. So it is finished in few seconds. So this D matrix, we can see it is same as the settlement points, with for each FID of settlement point we get 3 different target ID. So input ID is same as settlement points ID, and target ID is represented by airports. So we can find the name of the nearest 3 roads for each settlement point. So for that we need to join this with these 2 layers. So let us try to join it. So we can see that this join, and we have to join both this layers. So first we join with settlements, and join field is FID, and target field is input ID. Okay, and again we join with airport, join field is FID, and target field is target ID. We have done mistake here. With settlement we need to change it to input ID, so it is okay. So we can see that for airport ID we have chosen target ID, and for the settlement we have selected input ID. So now if we join, we can see that for each settlement, for example settlement name is Birpur and the nearest airport is Viratnagar airport. So for each settlement we have 3 different airports which are the nearest from this. Now we are going to talk about geoprocessing tools. Mostly used geoprocessing tools are buffer, intersection, and union. So in this tutorial we will learn these tools. So first of all, let us see what are these tools and the purpose of these tools. So for example, we have buffer, union, and intersection written here. So what is buffer? So let us say there is a point layer distributed like this. So if we buffer it, for example for 50 meters, so it will create a circle around it, and create a polygon which are which is at fixed distance from this point. So buffer will always create a polygon. So this is an example of point. So if we have a line, then it will create a buffer like this. So in this case, the buffer of both the lines are dissolved into one single polygon, but sometimes we can get this kind of buffer also. For example, this is one polygon and this is another polygon, so we will get an overlapping polygon. In similar way, we can get buffer of a polygon like this. So next I will tell you about intersection. So let us say we have two different layers. One is like M1 and M2, and another is N1 and N2. Now if we intersect these polygons layers, then we will get a new layer which has the common part between these two layers. So for example, if we move this from here to here, so for example it is like this, then the area which is common to these will be created as intersection, and it will have the attributes from both these layers. So let us see what is the output in our QGIS. So in case of union, uh, not only common area but uh, not common to both these polygons, like uh, this area will also be in the output, but it will have null value for one of the layers. So let us see in the QGIS. So I have prepared the data for this analysis, which is inside this sample practice.gpkg. So we can see here, this is the data we are going to use. So inside the sample practice I have two layers, so I will display both the layers, and then try to, first of all we will buffer this road vector, geoprocessing tool, buffer, and for example we create buffer of the road. So for example 100 meter, and run. So I keep the output as temporary layer and run. Ooh. So it is too big. I think we have done some mistake. So it is too much bigger compared to the road. So maybe we have done something wrong. Let us check. So we can see that it is the 4326. It is the coordinate reference system is geographic coordinate system. So 100 means 100 degree, which is not possible. So we need to convert it to UTM projection first. So let us convert it to UTM projection. Right click this one, and export, and I will save it in UTM projection. So the layer name will be road, and the new CRS will be EPSG 32645 because it is in 45M zone. And okay, but it will display at the same place because the coordinate reference system is same. In the same way, we convert this to same projection system. So we create a layer called soil, and the new projection system will be UTM zone 45N. So let us start a new project, and again we add the UTM data layer from here. In this today's practice we have created road and soil, so let us add this road and soil. Then you can see that the EPSG is changed to 32645. Now we can buffer. So if we check the length, so it is around 200 or 300 meters. So if we so it is around 400 meter. So maybe 100 meter will be too big, so we will create a 50 meter buffer. So vector, geoprocessing tool, and buffer we will use again, and we will buffer this line feature. And for example, we keep it 30 meter and create a temporary layer. Now we can see that these two layers are created. Sorry, these three features are created under this buffered polygon. So now we intersect this buffered layer with this SL soil layer. So but before that, let us check what is inside this. So it has soil type black, brown, gray, and red. So we will change the symbology to classified, categorized, and we'll use soil type and classified. So we change this color black, brown is okay, and gray, we'll choose gray. Okay, let us take it like that. So black, brown, and So we can see this black, brown, red and gray soil. So now we can use intersection and union tool. Let us see what happens. So vector, geoprocessing tool and intersection, and we will use soil and buffered layer and create an intersection, and again we will create an empty temporary layer. So intersection is here, so we cannot distinguish between buffered layer and intersection layer because it is below this. So we can see that the outer part which is not intersecting with either of these buffered or soil polygon are removed, and only the common part is shown here. So if we check the attributes comes from both the road and this soil type polygons. So let us check which polygon is represented by each features. So this small part with road name is belongs to this AA, and so it will be better if we label this road also. So this is AA, this is BB, and this is CC. So let us check the intersected polygons one by one. So this is from black soil type and BB road. Similar way, this is brown, this is also brown and BB, this is brown AA and this is brown BB, and this is gray AA and this is gray CC, and small part is from red and this the road called AA. So we can check all these parts. We can also select from here. For example, if we select this, so we have to select intersection here first, and then so this is the one feature we selected. So this is another feature. So there are few features which are overlapping. So this layer is also overlapping here. We cannot see because it is below another polygon. So this is the way we do intersection. And now we will try to do vector union. So as I told you, both the common and not common part will be selected and copied to the output layer. So we use this buffered layer, and overlay layer is the soil. So using these two we will create union. So we can see that both the overlapping part and non-overlapping part are selected. So if you check this non-overlapping part, we can see that this soil type is null here. Similarly, if we select this part, the soil type is black but road ID is null. So